Right. We looked into some attributes. So few were well known, and this one which I am showing here is well known. But the other three which we saw were mandatory. This is discretionary. And I remember we also saw MED as optional non-transitive. But we have not gone deep into understanding what is MED. Rest all in this list we have seen. AS path, next hop, origin, they are well known and mandatory. Local preference, well known and discretionary. MED is optional, non-transitive. What is local preference? It's a numerical value. When you set higher value on a router, that will be the exit. That will be the outbound traffic exit. That will be the exit for all that wants to go out of this autonomous system. For all here means for all routers in this autonomous system to go out to other autonomous system, the router with the higher local preference will be the preferred exit. In our example here, router 2 will be the exit in order to reach that 170.16.0.0 network. Though going via B is less number of hop counts. AS path comes after local preference. This is something which I did not tell you. 1, 2 hop. But if you go this way, it is 1, 2, and 3 hop. When I don't configure local preference, the default will be 100. In that case, all the routers will exit this way. But hey, where am I? But when the local preference is set, it will not focus on AS path. Why? AS path attribute comes after local preference. The sequence of attribute, the order in which the attributes are arranged, the order in which the attributes are going to be cross-checked before forwarding the traffic. If you see the order, you will find that AS path comes after local preference. So suppose I have a router here called C. It will definitely take this path. It will take this path. Only when the route is not found. For example, there is a cut here. So the route advertisement won't come. The route advertisement comes this way, but not the other way. So C will prefer going this way. That is automatic failover. You no need to do anything for that. local preference. When I configure out on router A, every router will know about the local preference of A because it is advertised, it is sent to all IBGP neighbor. The scope of this advertisement, this attribute advertisement, is within the AS, within the autonomous system. Now, MED. As I said, MED is an optional, non-transitive, multi-exit discriminator. Now, which one has got multiple exit? Router A has got multiple exit. In order to reach this, A has got multiple exit. But in the previous case, A has got only one exit. This autonomous system is dual homed, no doubt. Dual homed means what? This autonomous system is connected to two different autonomous systems. One is this direction, another one is this direction. They are two different autonomous systems. This is 65,000. This is 65,500. Two different autonomous systems. This is what called as multi-homed. Multi-homed. MED will not support you in this multi-homed environment. MED, when you have dual home, I have two connections up to the same autonomous system. I have two connections to the same autonomous system. We call it as dual homed. Only in dual home scenario, MED that you will tune will be useful. That you need to be very clear. Don't expect tuning MED will give you a desired path in this environment. No. In this environment, if an engineer is tuning MED, you can easily identify that this guy don't know BGP. You see, if an engineer is tuning MED in this type of topology, you can easily say that this fellow do not know about BGP. He may know how to enable BGP, but really he don't know how to use BGP effectively. Using BGP effectively depends on the knowledge of attributes that you got. So, though the word is interesting, MED, multi-exit discriminator, though many people do not know about these abbreviations, all those stuff, I tell you, because you know it, you don't go and tune it. That's not good for us. You only think MED as an option if your autonomous system has dual home, two connections to the same upstream ISP. Okay, now coming to the point. When I have more than one connection, who is me? A. I can reach this network via C or via B, P or C. Let's say you're going via this path. And ISP is telling you to take this path. But your router is taking via C. And ISP is advising you to use via B as a primary and C as a backup. ISP is advising you to use B as a next hop. But you say, I don't know BGP. I know how to enable BGP. I have enabled BGP. What to do? I cannot do anything. That BGP only going to B. Sorry, that BGP is only going to C. It's not my mistake. I enabled BGP. That BGP only I have to blame. BGP is saying, I will go via C. What can I do? So that's the level of BGP that I know. So I am saying, you asked me to enable BGP, man. I enabled. But what to do? BGP is taking this path. Now ISP will do their job. Oh, ISP will say, okay. You don't need to do anything. We will take care. What ISP will do, when they advertise this network from B, they advertise with MED lower than the other one. Lower is preferred. So A is receiving with MED 150 from B and receiving update from C, the same update, but with 200. Now A will pick only the lowest MED. A says, I take this path. Did you configure anything on A for this to achieve this? No. ISP did some change there. As a result, your router started picking up this path. This is the only attribute that impacts the other autonomous system. MED is used to advertise to eBGP neighbor. MED tells the eBGP neighbor how to exit their autonomous system in order to reach the network owned by this autonomous system. So BNC advertises to an eBGP, which is A, router A here. On receiving this update with different MED, A decides to choose the path via the neighbor that gave smallest, lowest MED value. Lowest MED value are most desirable. The path with the lowest MED value or the most desirable. MED is used to advertise to eBGP neighbor how to exit their autonomous system to reach network owned by this autonomous system. The MED attribute is an optional and non-transitive. What does that mean? If MED is not there in the advertisement, then that advertisement is not a valid one. The default MED is 0. If you don't set this 100, this 200, the default MED 0 must come, because it will become non-transitive if it is not found. A will not use it if that MED is not found when B and C advertises. Even though MED will not be used in this circumstances, even though in this circumstances MED is not used, that's why we call this optional. MED is not always used. MED is used only when dual homing scenario is. That's why it is not coming under mandatory, it is coming under optional. Why? It won't suit here. But even here, when the advertisement comes, it should come with the MED. Whether it is used or not, I should see it. If I don't see it, I can't use it. See, that's what we learned when we learned optional non-transitive. I discard it if not recognized. At least that 0 should be there. Do you have any question on MED? What about others?
Sir, MED we configured by only the ASP side, or the B, you mean ASP, right? B and C.
B and C are, it may be ISP, it may be your partner autonomous. Yeah, mostly it is ISP. Yes.
But we need to configure only one neighbor, right? Not the neighbor and market, right?
See, in case you also have a server here and a public IP address here, and you allow someone from outside to use your server, and you don't want them to come this way, you want them to come this way, then also you will set the MED and advertise. Remember, when you provide a service, you are also a service provider. In your meaning, service provider is an ISP, internet service provider. But not only an internet service provider uses this MED. Yeah, mostly MEDs are used by internet service provider, but there are some companies who provide service, web server, they share to the public. Many companies have got their own web page and they maintain their own web server. In that case, even the enterprises which is sharing some service can also go with MED if they have dual homed. So anyone can use it. Whoever wants this option can use it. It's not for only ISP. That is what I want to tell you. But as you said, yes, mostly we see ISPs are using MED than a normal enterprises. Any other question? Wait is a Cisco proprietary attribute, but I have seen the same word WEIGHT in Huawei. In Juniper, they call this preference, not the local preference. That is different. Local preference is well-known mandatory. It's the same thing in Juniper, Huawei, everywhere. But this one particular weight, weight is called as preference value, preference in BGP, Juniper. In Huawei, it's the same word weight. And it's the same meaning also. Same word, same meaning. Whatever you learn here is the same thing there. Every vendor has got something equal to this attribute weight. Only the name will differ, but they all have this meaning that you're going to learn for weight. Same meaning, different word they use. What is weight? Again, it's a numerical value that we set to a neighbor, saying that whatever that neighbor gives me should be taken more serious than the other neighbor giving me. B is giving me, C is giving me. Who am I? I am A. I am A. B is giving me, C is giving me, but for me B is more weightage guy. B also gives the same 172.20.00 network like C. Both are giving me. But for me, for me, more weightage is to B. Whatever B gives me, though the other guy may also give me the same, but I don't go with the other guy, I go with this guy. In that case, we use this weight. What is the difference between weight and local preference? Weight in which router you configure, only on that router it is going to have a impact. I configure weight on router A saying whatever the update coming, see this network it will be advertised to A from B, by B, by C. Both are advertising, B and C are advertising about that network. But in A, I have set 200 for B, so the advertisement given by B is more preferred, more attention given than the advertisement given by C. Only if B fails to give some network and C gives that, only for those network it will go via C. Whatever I configure here will not be advertised to anyone, not to IBGP, not to EBGP, not to anyone. It is local to that router where you configure. Whereas in local preference, whatever I configure on router A goes even to router C and also to B. It is spread to everyone. It informs everyone that A is the best exit. Whereas here, that will be kept local to the router, will not be sent to anyone, neither IBGP nor EBGP. It's local to the router. Local preference is local to the autonomous system. Weight is local to the router. Both are higher is preferred. Highest weight value is preferred. Local preference is also highest local preference. Any question on weight? Okay. Now let us see this is giving you some very important routing knowledge. This page is giving you very important routing knowledge. See, BGP is a wonderful protocol, very big protocol. People, those who know BGP are more respected than those who don't know BGP in networking world. All those things are true, no doubt. All those things are true. There is no doubt. But is BGP always most important? No. No. Wherever it is really needed, only there it will be used. Because it is very important protocol, it cannot be used wherever you want. So what the designer did is, what the designers have done is, they have designed in such a way that so what the designers have done is, administrative distance they have given higher for IBGP, higher than RIP. Administrative distance lower is always preferred. So you see, a route is given by BGP as well as by some other IGP protocol. A route is given to an IBGP router, and also the same route is given by another protocol. Which one the routing table manager will use? Routing table manager will use only the route that has got lower administrative distance. So this is how the lower administrative distance route is preferred rather than IBGP route, which is 200. Due to this we get what? RIB failure. We have discussed this earlier. So what I am trying to say here is, don't expect BGP route because you enabled BGP route, BGP in the router as a routing protocol. Now this BGP protocol is not designed to perform a load balancing. This is another reason why BGP is not preferred inside the autonomous system. OSPF is preferred. Even RIP is preferred than IBGP. IBGP is 200. Inside the autonomous system, you wish to have load balancing. BGP is not designed to perform load balancing. BGP is only to choose a best path as per the policy requirement. Not the best path based on the hop count or delay value or bandwidth value. BGP will eliminate and choose only one single path. So BGP is going to be giving you the best path outside the autonomous system. But the inside is determined by IBGP if IBGP also have got the same network info. Sorry, IGP. IGP is having a network. IBGP also has the same network. because inside IGP is preferred, IGP does multipathing. And when it goes outside the autonomous system, BGP takes over. BGP's administrative distance is 20, and BGP will not do load balancing. BGP will only use the policy and say, for this policy, this is the best path, because the attribute matches with local preference or weight or origin, something like that. It will pick one best reason and say, because of this policy reason, I choose this one single path by ignoring the other paths. Alright, so do not expect always BGP, BGP, BGP everywhere. Because you enabled BGP, it's not going to be there everywhere. Again, there are rules. Administrative distance, if some other protocol also advertises the same network what IBGP advertises, then you won't see BGP route in the routing table. Even though it is there in the BGP table, it will be considered as a rib failure. Only IGP given routes will be used. This is for you to know how a normal routing works. Now this is the important page. Hooray. This is the sequence in which the attribute list arranged. Now when an update arrives, update is arriving from different neighbor. See, we are not talking about ping packet. Route update is coming. BGP's route update is coming. First thing is the next hop a valid, reachable next hop? Very important. That's a very important attribute. Next hop is an attribute. And that next hop should be a reachable next hop. If not, what we used to do? If the next hop is unreachable, what we used to do? Let's see who answers this question. If the next hop is unreachable, what do? Don't say we write static route. That's not the good way. We change the next hop by writing what? That's good. Next hop self. So we do some tuning like next hop self to make a next hop a valid next hop. Fine. Now you got an autonomous system with dual homing, multi-homing. And this router now has got a reachable next hop. This next hop is also reachable. This next hop is also reachable. You are learning update from two different directions. ISP1, ISP2. And both have got valid next hop, which means what? There is a tie. Then which ISP it will choose? It will compare it will check whether the weight has been configured. In case if this router has got weight set to this neighbor, then that is the tie break. Router A will try to go this way only, ISP1. If weight is not configured, you have valid next hop, both the next hops are valid, going via B, going via C, both are valid next hop. And for both weight is 0. What is the default weight? 0. We saw that, right? Oh, they didn't mention here. The default weight is 0. When you don't configure wait, it will check whether local preference is configured. If you would have configured here 200 local preference, the default is 100 here. In this case, the tiebreaker is local preference. All the router will go this way, even including B. Will go via C to ISP2, not via B to ISP1, but via C to ISP2, because you have configured local preference. If in case you don't configure local preference, again there is a tie. Now what is the tie breaker? The origin, not origin code, origin. Is it locally origined? In our case, both are coming from outside. If one says coming from B, another says we also have local same network on A, the next stop is 000. In that case, weight will automatically increase to 32768. I'll show you that. If the local origin, if the next stop is 0000, this weight will automatically come to 32768, so that the very first attribute will be the tiebreaker. So local origin takes preference. If all are coming from outside, then this will be a tie, and tiebreaker may be AS path. If one has got less number of AS in the path than the other, it prefers the lowest AS path. For example, in this scenario, if you don't set local preference, then this will be the best exit. Only 2 hops, less AS path. This way is 1, 2, and 3. This is 3, this is 2. See, again, you need to understand, it will decide based on attribute 4 only if there is a tie in the above. If you would have set local preference, it will not come here. It won't check. Only if there is a tie, it goes to the next and goes till there is a tiebreaker. So, if there is a tie in this also, both direction, the AS path has got same hops, then only it will compare the origin code. Listen, we learned about origin code. I is smaller than E is smaller than question mark. But you need to understand, when will this come as a tiebreaker? Only if there is a tie in these 4. See, you should know this order, the sequence. Only then you will know what attribute to tune to achieve the path that you want. Do you understand? Knowing this in a order, in sequence, by heart, is an important one, very important one. You should know this in by heart. Now, only when there is tie in all this, it will check MED, but MED is needed only if what? Dual home. If not, no need. If not, it will come to the 7th attribute. In 7th attribute, it will check if one of the neighbor is EBGP, Another is IBGP. If yes, it prefers to go via EBGP than IBGP. What if both are IBGP? If both are IBGP, to reach that IBGP neighbor, it will check the cost, like OSPF cost. See, you have two IBGP neighbor, which means what? Your neighbors are inside your own autonomous system. Prefers the path through the closest IGP neighbor. Meaning it will check how much is the metric to go to that IBGP and this IBGP, and it decides to go via the IBGP neighbor whose IGP cost is lower. Okay, closest IGP. This IGP may be RIP. To one IBGP it is 2 hop. To another IBGP it is 1 hop. Which one it will take? The 1 hop IBGP. If there is tie in this, assume that the IGP cost is same. And if, okay, sorry, this is IGP, right? Now, what if both are EBGP? Then the neighbor, EBGP neighbor, that gave route first, oldest route. The oldest means what? It came first. That is preferred. Now what if there is a tie-in that both the EBGP neighbor gave the route at the same time, same milli, micro, nanosecond? In that case, it prefers the neighbor whose router ID is lower. Definitely this will be a tiebreaker. No two EBGP neighbors will have same router ID, right? So one will be lower than the other. Let us say, just for an argument, there is a tie in this. Then comes this one. Lowest neighbor IP address. Will there be two neighbor with same IP address? No way. In network, in public network, it is not possible. So one will be lower than the other. See how BGP picks that one path by eliminating multiple paths. It is only based on the policy, based on the attributes that you configure, not based on any other metric. So I encourage you to go through this video. I encourage you to memorize this in order. It is very easy to remember. For me, at any time I can say this is attribute number 6 MED. Attribute number 9 is oldest route. But I did not really memorize it. It came just like that in my mind. It registered in my mind. That may be the same experience you may have now. Anyway, you should know this in order. Try memorizing or keeping this in order in your mind. We will learn more about attributes and then we'll get into lab in coming days. Do you have any question? Okay.